Hello students. So in this video we are going to solve some problems on integration. Okay, why we are spending some time on this? Because these are the very important tools to work out questions in physics. We will see the applications also, and it will start from the next chapter, that means kinematics. Okay, so let's start. This is the first question. Evaluate integration of root under 1 plus y square to y dy. How to solve this type of question? Okay, we don't have direct formula, but we learn how to solve it by substitution. Okay, this is called method of substitution. Let's understand this. So what we are going to do, we are going to keep 1 plus y square as z, and if there is a limit also, limit will also change according to that. Okay, so let's take this is 1 plus y square is equal to z. Then when you differentiate this side, this will become constant differentiation of 1 is 0, right? Y square differentiation is 2y dy is equal to dz. If you want, you may write it also like, differentiation with respect to, dz with respect to y. If you do that, this is 0, y square is 2y. So you can say 2y dy is equal to dz, right? This you are going to substitute in this integration. Okay, so in this integration you can clearly see that there is 2y dy term. 2y dy you are going to substitute. So let's substitute. What happens? This integration limit also you have to change if there is a limit. Okay, so then this will become root under, this is a whole z, right? And this is 2y dy is dz. Now you can see this looks very clear, isn't it? Because this is z to power half dz. Now you apply the integration formula, z to power n plus 1 by n plus 1, right? So this becomes z to power 3 by 2, isn't it? And this is 3 by 2, so 2 by 3 plus some constant you can add, and finally if you want z value you can substitute. So 2 by 3, 1 plus y square power 3 by 2 plus constant of integration. Okay, if there is limits, then you can put upper limit minus lower limit. So this is how we can solve this question. Let's move to the next question. Next question, evaluate this. Now how to do? Again, method of substitution we have to use. So what do we substitute? We have to think of that. So here you can see this 1 plus tan of this, right? 1 plus tan of this. This whole thing 1 plus tan of this can be substituted, right? 1 plus tan of this, it is v, let us say. Okay, and this you can write as z. Again you can do the same thing, dz by dv you do, differentiation of 1 is 0, tan differentiation, right? Tan differentiation is secant square v. So from here secant square v dv can be clubbed together as dz, isn't it? Because this term secant square v and dv can be clubbed together, right? So what do you get? Then you get this integration as e per power 1 plus this is z, and this becomes dz. Now so easy, e per power z, integration is e per power z only, right? And then you can substitute z back, 1 plus tan v and plus constant of integration, right? It's indefinite integration. Easy. It looks like difficult, but it is easy. And in maths you will be separately solving more different types of questions, but here some basic I am discussing, so that in case if some questions come where you have to solve problems using the integration, you should be able to do it. Okay, it's nothing we are living here in physics. Okay, then let's do this one, cos square 2 theta. So this can be written as integration of secant square 2 theta d theta. Now this can be directly done without substitution, because secant square theta integration, tan, it is tan, and whatever angle, that angle will come, and the coefficient of theta that is getting divided, that you remember. directly in one step you will do that. Okay, like this the coefficient gets divided. Okay, next. Now see some applications here. Kinetic energy of a particle in SHM, simple harmonic motion. This is how kinetic energy changes, right? With x. Calculate the average value of kinetic energy between x0 and so average value. How average value is calculated? Suppose y is equal to f of x. Y is a function of x. So if between x1 and x2, if you have to calculate the average value between this, so the average value definition is integration of y dx by integration of dx. This is what is the average, and limits you can put. Let's say limit is x1 to x2. Here also limit is from x1 to x2, right? So this becomes, and the denominator becomes delta x, because integration of dx will be x and upper limit minus lower limit is x2 minus x1. So you can say that this is what it is, y dx, and between the limits means this limit x1 x2 is there. So this is the formula to calculate average. Okay, integration. So that's what we have to do. We have to do the integration. So kinetic energy average value will be calculated as kinetic energy which is given as a function of x, right? And this is delta x. Delta x here means a minus 0, which is a only, right? And this is going from 0 to a. So let's do that. So there are half m omega. If you want to break this, let's break this. So half m omega square. Anyway, half m omega square is common. If you want to take out, then you are left with a square minus x square integration, right? This is dx, and a I am thinking this set, and it is 0 to a, right? This is what you have to integrate. So let's integrate. So m omega square by 2a has come out, and then separate it. So a square with respect to dx you do. A square is constant, comes out. Integration of dx is nothing but x, right? Minus x square integration. X square integration is x cubed by 3, right? And you are going from 0 to a. So let's substitute it. So when you substitute it, you will get m omega square by 2a. Upper limit and lower limit will be 0 only, right? So a cube minus a cube by 3. So it will become how much? 2 by 3 a cube, correct? So finally this a term will get cancelled. You will get m omega square a square, right, divided by 3. Okay, this will be the average value. So you can do the calculation in this way. This is the application in SHM. Average value calculation is done using this formula. For any kind of function, average between two limits, we can do like this. Next, this is a average. This is also application alternating current chapter. You will see that. Okay, average value of alternating current. Current is changing with time. Okay, its average value 0 to pi by omega. So let's calculate average value. So average value integration is I is a function of time. Okay, and the time is going from 0 to pi by omega. So the interval is pi by omega, right? So here you will get omega by pi, integration of 0 to pi by omega. I is I naught sine omega t dt. Okay, so I naught is constant, take out. I naught has come out. Sine integration is minus cos omega t. Remember, the coefficient of time omega will get divided here. You have to bring it outside, and this is going from 0 to pi by omega. So from here this omega factor will get cancelled. So you will get I naught by pi. Now you substitute minus cos upper limit. Time you have to put as pi by omega. So omega t means it will become pi, right? Because time when you put pi by omega will get cancelled. Okay, minus plus cos 0. So what do you get from here? Cos pi is minus 1, minus plus 1. Cos 0 is also 1, 2. it will become 2I0 by pi, right? So this is how you can solve this. Okay, these are some applications. Then let's take this question. So how can we work out this type of problems? Again, if substitution is going to work, you should use it. Think in terms of substitution. Okay, so what we can do is we can put 2 plus cos x. Let's put this 2 plus cos x. I'm going to put as z. So dz by dx. Constant differentiation 0. Cost differentiation is minus sin x. Right. So you will get from here sin x dx can be written as minus dz. So now this thing you are going to substitute in this. So this you are going to modify. This integration will become 6 by 2 plus cos x is z, right? So z cube, and sin x dx is minus dz. So minus dz. Now this becomes so easy, right? So minus 6 z power minus 3 dz. So minus 6 is constant, comes out, z power minus 3, z power minus 3 plus 1 by minus 3 plus 1. This is the integration, right? So of course there is no limit, so we'll add a constant of integration. So what you will get from here, you will get this is minus 2 here and z to the power minus 2. So this will become minus will get cancelled, it will become 3 z square plus constant of integration, right? So like this you can do. So this is how we can work out quotients. Okay, then let's take another question. 1 by t square cos of this. Again you try to substitute. Now this, it may look what it is, how to substitute. So always try to substitute in such a manner that you get, this type of form will be there, like f of x and f dash x dx will come. Okay, because f of x, when you substitute something, so f dash dx will come, it can form a group. For example, here 1 by t minus 1 when you put as z, then when you differentiate it, so dz by dt with respect to t. So 1 by t differentiation is minus 1 by t square, right? And differentiation of 1 is 0. So from here dt by t square can be written as minus dz. Now once you got this you can substitute here. So the integration will transform as cos of z, and 1 by t square dt is minus dz. So it will become minus, right? So from here then cos integration is sine, so it will become sin z plus constant of integration. Okay, so in this manner you can solve out these problems. Okay, so I hope you have understood these questions, and this will be very much helpful in solving problems. Okay, thank you.